So a function, you need to think about it as a bending machine. So I'm going to make a rectangle right here so it gives you an idea of a bending machine. In this bending machine, you have different buttons, and in this case, we're going to draw a button that is going to be a W for water. And then you're going to have another button for Coke. And then you're going to have another one for, let's say, iced tea. So I'm just going to put an I right here. And then I'm going to put for sparkling water, I'll put an S right there. So now this is where the drinks are going to be coming out from. So in a bending machine, if you press water, the things that are going to be coming out should be water. That is going to be the pattern that is going to follow. If you press Coke, you're going to be expecting a Coke to come out from here, and you guys are going to be happy. Now, let's say you actually press Coke. So you press this one. But then in the output, the first time you press it, you're going to get water. Then you're going to be really upset because you really, really wanted Coke. So you press it again because you really want that Coke. You press it again, but this time you get sparkling water. And you're like, bubbly water without flavor, that's not my favorite. So now you're really, really angry. So you're really, really angry because you're not getting what you want. You go and you press it one more time. You're like, okay. You press it one more time. Now, in this case, you get iced tea. So after 3 tries, you get different items. You didn't even get your Coke. So you press the machine over and over and it didn't give you the outcome that you were expecting. So we can actually say that this machine, this bending machine, is not functioning properly, right? So a function has an input, in this case the button that we're choosing, but it also has an output. So right now we're going to make another drawing, and please excuse my not so professional drawings. We have, imagine here a machine. This machine is going to have 3 parts. Okay. The first part is going to be your input. And whenever we're talking about input, the thing that should come to mind is your X values. So we need to have X values, and then our function machine, a function machine that will give you a rule. It's going to tell you exactly what's going on. And then you're going to have an output. And that output is going to be your Y value. You can also see this as a car wash. Your input is going to be a dirty car. After you go through the car wash, you're going to come out with a clean car. Okay? That is the expected outcome that we're going to be looking for. But now let's try to make a little more sense of this. Let's say we have a function, and your function is going to be y equals x plus 2. So that means that your rule is going to be x plus 2. And then the numbers that we're going to be using in this case is going to be, your x is going to be 1, 2, and 3. So if you put a 1 through your function, you're going to put 1 where the x goes, and that's going to give you 1 plus 2. So your outcome is going to be 3. If you continue the same process, when you put a 2, you're going to get a 4. And when you put a 3, it will give you a 5. So that is an example of an equation, and we also have it as a table. Functions can be represented in many different ways. That includes an equation like you have on the left side. You can also have a table, but we're also going to be talking about diagrams and also graphs. Most of the equations you're going to be dealing with in 8th grade and even in Algebra 1 are going to be linear or quadratic. Now, those are actually functions. Every time you see something similar to y equals 2x, this is going to be a linear function. It's going to create a straight line. You can also get y is equal to x. You can get y is equal to any number, let's say 8. It's going to be creating, again, linear functions, so we know it's going to be able to work. Every time you have an equation like that, you're able to put it into a table like we did in the previous example. You have an equation, you choose your numbers, it will give you a precise table. Now, they can get a little more creative too. You're able to have y minus 1 equals 3x, which is totally acceptable. You can always change that and leave the y by itself. Another way that you're going to see this is adding exponents. So let's say if I give you x to the second power minus 2, that's also a function. And lastly, let's make it a little more funky. So we can even have 1 over x plus 3. Okay, that's not your typical equation that you're going to see in 8th grade, yet those are all examples of functions. So those are all functions. The only time you're going to be dealing with things that are not function, and I want to draw a line right here so you know that these are not a function. It's not going to be a function anytime you have x equal any number. Okay, so that can be x equal 1, x equal 14, x equal negative 25. And sometimes people are going to try to trick you, and they may give you x minus 1 equals 3. Whenever you have an x by itself giving you a number, you're actually not going to get a function. Whenever you transfer an equation into a graph, the x will give you a vertical line, which is, again, not a function. And that's going to take us to the next point. A graph will always look something like this. It's going to be in a coordinate plane, which the proper term is a Cartesian plane after René Descartes. Now, if you have a line that looks something like this, to understand if this is a function or not, what you're going to be doing is creating what we call a vertical line test. So we're going to add that vertical line test. Keep in mind that whenever we're talking about functions, we can also try to use that term into something more familiar, like how your body functions. You're trying to see if something works. Now, if I'm telling you that we're trying to figure out if this is a function and we're going to use a test to figure out if it works, usually we use tests to determine if the given body part or organ is working properly or not. So this is exactly what's going to be doing, but for math. So now we're going to draw a vertical line through various points on our graph. Now, the vertical line test is going to tell us whether that is a function or not. If the vertical line that we're drawing only touches one point, it is a function. That's simple. So in this case, we have a vertical line right here that only touched this point right here. Then that's fine. It follows the rule. If we keep going right here, again, we draw another vertical line, it touches one point, that's fine. And as we continue, again, we draw it again, and you see, only touches one point. This is going to be a great example of a function. Now, let's look at an example that is not a function. So we're going to draw again our coordinate plane. And we are actually going to draw a circle in the middle. If you draw a vertical line at the edge, you're going to see that it actually only touches one point. And I'm sorry, it's not a circle, it's an oval. I'm not that good at drawing circles. I'm going to drop another line closer to the middle. And now look, you have one point right here that is touching, but at the same time, the vertical line is touching another point right here. That means that this is not a function. So let's write it down. Not a function. And you should know that the explanation is when you do the vertical line test, it touches more than one point. And that's pretty much it. Now, we mentioned that an equation, it gives you a graph. So if I give you, for example, y is equal to 2, for the equation y is equal to 2, that means that for every single value, doesn't matter what we choose, there's going to be a horizontal line that goes through the point of 2. Now, if you conduct the vertical line test there, you know that it only touches one point, and that's totally fine. Let's say I give you another function. I want to write it as y equals x. If I give you a y equals x, this is going to be a linear function that we're going to be covering next week is going to look something like this. And if we do a vertical line test on the blue line, again, we're only going to see that it only touches 1 point. But let's look at one more case. If you have x is equal to 2. X equal to 2 is going to actually give you a vertical line that goes through this point, like this. We know that the vertical line test says that it can only touch 1 point. And in this case, if you draw a vertical line through that line, it touches every single point. Therefore, it's not a function. Lastly, you need to understand that some functions are going to be linear like this. So you're going to be able to see them and it's going to create a straight line. Some of them are actually going to give you like a semicircle, which is totally fine. Now, there are some functions, and I need you to keep this in mind because it will be on your quiz. Some functions are actually going to be only points. But if you have a graph that only has points, you follow the same rule. You do the vertical line test and see if it touches more than 1 point. In this case, we can actually draw it through every single point. And it doesn't touch more than 1 point, therefore it is a function. The next one is tables. Again, we have been dealing with tables for a while now. So we're going to draw a table. The first one I'm going to draw is a horizontal table. And just keep in mind that whenever you have a horizontal table, even if they don't label it, the first one is going to be your x, the second one is going to be your y. And now we're going to fill it in. We're going to put 1, 2, 3, 4. And we're actually going to get 8, 20, 31, 42. And then we're going to look at a different table. This is going to be vertical. Again, the first one is going to be your x. The second one is going to be your y. Keep in mind, let's make a note. X equals input and y equals output. And in this case, we're going to put 1, 8, 2, 8, 3, 4, and 5, -1. For both of this, we have examples of functions. How do we know they're functions? You're going to be looking at the input values. So you're going to be looking at your x's. And then you need to make sure that they only have one output value. So 1 goes to 8, which is totally fine. 2 goes to 20, again, it's fine. 3 to 31, and 4 to 42. These input values are not repeating anywhere, which means this is a function. Now, let's look at the second table right here. We have 1 goes to 8, 2 goes to 8. Now, a lot of people get confused right here because they say, well, the outputs are repeating. But you need to keep in mind, again, going back to the example of a vending machine. Some vending machines will sell you the same thing, even though you have to press 2 different buttons. Especially if you're in a school and they don't let you sell soda, then you're going to have a couple different buttons that are going to give you water, which is fine. But that means that it's working. As long as, again, you press the button for water and you get water, it's fine. Then 3 goes to 4 and 5 goes to -1. Okay? Those are all examples of functions and everything works in this case. Now, let's look at a table that is not a function. We're only going to be looking at one. So we're going to draw this table. This is going to be your X. This is going to be your Y. In this case, this is not going to be a function because when you go from 1 to 4, 2 to 3, 3 to 1, and then you get again 1 to 8. The fact that if you press the 1 button and you get an 8, or you may press the 1 button and get a 4, that means that it's not working because your outcomes are different. So we're going to make a note of that. 1 input must only have one output. Okay, one input must only have one output. Lastly, we're going to be working with diagrams. Diagrams, again, you're going to be drawing ovals. The first one is going to be your input or your X, and the next one is going to be your output. So X and Y. So your input, in this case, is going to be 1, 2, 3. And your outputs, we're going to put 9, 8, 17. So if 1 goes to 9, 2 goes to 17, and 3 goes to 8, this is a great example of a function. Every single input has one output. You can actually change this into a table if that makes it easier for you. Now, some of the diagrams are going to look a little bit different. For example, this one. This one, your first diagram, is only going to have one input. But it's going to give you 3 different outputs, which means that is not a function. Because if you press the button for 4, you may get 1, you may get 2, or you may get 3, which is not what you're looking for. So, right now, we're going to do another example where you have multiple inputs going to one output. This is totally fine. You're able to have multiple inputs going to the same output, and that would still be